Good day, everyone. So this day we will tackle about the rules of replacement. So there are 13 rules of replacement, but I will discuss only the 10 rules of replacement. And these rules of replacement is used in proving. So we can simply prove mathematical equations with the use of these rules of replacement. So we will begin. So the first rule of replacement is all about the commutativity or the commutation. So when we say commutation, the rule of replacement called commutation or the com shows that statements of certain forms can simply be reversed. So when we say reverse, nababaliktad po ito. So in one form, this applies to all disjunctions. So when we say disjunctions, it is the or, and the sign of this disjunction is this one, like V. This is disjunctions or. Then we have here the quantity of P or Q is equivalent to the quantity of Q or P. And as you can see P and Q ay binaliktad into Q and P. So this is P or Q is equivalent to Q or P. That is for the disjunction. And we have here the truth table. So we have here the P and the Q. So we will find the value of the P or Q and the Q or P. Sorry for that. Okay. So for example, for P, we have here the T, and for the Q is we have here F. And if this P and this T is equals to 5 and the value of F is equals to 2, and by the way, if we will say disjunctions, we will find the value of the maximum value. Again, if disjunctions or the or, we will find the maximum value. And for example, this is 5 and this is 2, so the maximum value is equals to C or the 5. So that's why we have here the value of T. And if what is the value of this one is also the value of this one, because they are equivalent. And as you can see, the equivalence here, we have also here T, because this statement is true. So that's it. And in its second form, commutation establishes the same logical equivalence with respect to conjunctions. Kung pinag-usapan natin kanina si disjunctions, ngayon pag-uusapan natin si conjunctions. So when we say conjunctions, it is the end. So and the sign of this conjunctions is this one, or that. That is the sign of the conjunctions. So this one, we have here the quantity of P and Q is equivalent to the quantity of Q and P. So binaliktad rin po ito. And the sign is conjunction. This is that, or we can also have this one. So we have also here the truth table. And we have here the P, the value of P and the value of Q, and we will find the value of P and Q, and the value of Q and P. And if the disjunction, we will find the maximum value. In this conjunction, we will also find the minimum value. For example, for P, we have here the T, and T is equals to 5, and F is equals to 2. And if we will find the minimum value, so the minimum value is equals to F, because F is equals to 2. And again, if what is the result of this one, is also the result of this one, because they are equivalent. So for example, we have here F. F stands for the Francisco Studies Logic, and J, John studies logic, so therefore, F or J is logically equivalent to J or F. or we can say that Francisco and John studies logic, and John or Francisco studies logic. And if we have here A stands for Anna goes to the movies, and L, Linda goes to the movies. So therefore, A and L is logically equivalent to L and A. Or Anna, sorry for that. So therefore, Anna and Linda goes to the movies, or Linda and Anna goes to the movies. So that is for the commutation. And the second rule of replacement is all about the association. So association, or the ASOC, permits modification of the parenthetical grouping of certain statements. So applied to this junction, it has the form. So disjunctions muna po tayo. So disjunction, so we have here the quantity of P or Q or R is equivalent to P or the quantity of Q or R. So ginamit po natin si disjunction sa ating association. So we have here the truth table. So we have here the P, the Q, and the R. So we will find the value of P or the quantity of Q or R, or the quantity of P or Q or R. So for example, for P, we have the value of here of T. And for our Q is F, and our R is T. So if we will find the value of P or the quantity of Q or R, so when we say or, it's the maximum value. So this one, T, if this one, F or T, so the answer is T because the maximum value is T. And P or R, T and T is equals to T. So that's why we have here T. And if what is the answer of this one is also the answer of this one because they are equivalent. So that is for the association used by the disjunction. So next, this shows that the grouping of a string of disjunctions is irrelevant to the truth value of the compound statement form. Then, applied to conjunction, it has the form. Kung disjunctions kanina, ngayon, conjunction naman. So, for conjunction, we have here the quantity of P and Q and R is equivalent to P and the quantity of Q and R. Okay, sorry for that. So, used in tandem, the commutative and associative replacement rules make it possible to rearrange any series of disjunctions or conjunctions, no matter how long and complicated, into any new order and arrangement we wish to have. So we have here the truth table for conjunctions. We have here the P, the Q, and the R. So we will find the P and the quantity of Q and R, and the quantity of P and Q and R. So for example, we have here the T, and the F. So conjunctions. So when we say conjunctions again, it is the minimum value. So if we will find the minimum value of Q and R, so T and F, so the minimum value is F. And if we will find R and P, so the minimum value F and T is equals to F. And if what is the answer of this one is also the answer of this one because they are equivalent. So that is the association. So for example, I have here an example. So A, Anna goes to the movies. L, Linda goes to the movies. And D, Tom goes to the movies. So therefore, A or the quantity of L or T is logically equivalent to the quantity of A or L or T. Or therefore, Anna and Linda and Tom goes to the movies. Or Anna goes to the movies, or Linda or Anna or Tom goes to the movies. Or we also can say that Anna or Linda goes to the movies, or Tom goes to the movies. And we also have here Anna goes to the movies and Linda and Tom goes to the movies. Or we can also say that Anna and Linda goes to the movies and Tom goes to the movies. So that is for the association. So now we will move on to the distribution. So distribution, the rule called distribution or the DIS, exhibits the systematic features of statements in which both disjunctions and conjunctions appear. So in one of its two forms, a conjunct is distributed over a disjunction. So pinagsama natin si conjunctions and si disjunctions. So in logic, just as in mathematics, so it is possible for us to distribute propositions across a parenthesis as long as the resultant proposition is equivalent to the original proposition. So we have here the P and the quantity of Q or R is equivalent to P and Q or the quantity of P and R. So distribute. So for example, we have here P times Q is equals to P and Q. Then P times R is equals to P and R. So dito po ay or siya, or. So that is distribution. So we have here the truth table. So we have here the quantity of the P, the Q, and the R. So we will find the P and the quantity of Q and R and P and Q or P and R. So for example, so we have here, I'm sorry for that. So distribution. So we have here the truth table for distribution. So we will find first the value of Q or R. So Q or R. So we have here T for Q, and for R is we have here the F. And this is OR, so therefore we will find the maximum value. So the maximum value of this one and this one is the T. So T. And if we will find P and Q, so we will find the maximum value because minimum value because that is end. So since that this is T and this is also T, so therefore the answer is T. And if what is the answer of this one is also the answer of this one because they are equivalent to each other. So that is distribution. Distribute. And we also have here the truth table for P or the quantity of Q and R. Then we also have here the P or Q and the quantity of P or R. So for example, we have here F for P, and for Q we also have here F, and for R we also have here F. And if we will find Q and R, so that is the minimum. So the minimum value is F. And if we will find the Q or P. So we will find the maximum since that this is F and this is F. So the answer is F. And what is the answer of this one is also the answer of this one. So in the other form, a disjunct is distributed over a disconjunction. So ito po ito. This is the truth table. So the truth table should make it clear that both forms of distribution are reliable rules of replacement. This is reliable. Hindi ko po ito ginawa. Sorry for that. So for instance, the proposition, John is singing while either Philip is sleeping or Mary is studying. So therefore, P and the quantity of Q or R can be replaced by either John is singing and Philip is sleeping, or John is singing and Philip is sleeping, or John is singing and Mary is studying. So therefore, P and Q, or the quantity of P and R. So that is the distribution. Now we will move on to the De Morgan's theorem. So, okay, sorry for that. Okay, the forms of De Morgan theorem are as follows. So we have here, so this one we call it as not, because this is negative not. So not P and Q is equivalent to not P or not Q. And we also have here not P or Q is equivalent to not P and not Q. So if we will look at this one, so this is in mathematics, or so this is negative times positive is equals to negative. Negative times positive is equals to negative. So that's it. De Morgan's theorem allows substitution of disjunction for conjunction and vice versa. So the first form above allows the replacement, this one, allows the replacement of a negated conjunction for a disjunction in which the quality is changed from positive to negative. So the second form, this form, allows the replacement of a negated disjunction for a conjunction in which the quality is changed from positive to negative. Of course, since these propositions are equivalent, the replacement can be carried out in the opposite direction. So, just as in rules of inference, so there are also variations in rules of replacement in terms of quality of propositions. That is, on negation and affirmation. So, for example, if we negate the P in the proposition not P and Q, so that it would look like this: not P and not P and Q. Then its equivalent will also change, will look like this one: P or not Q. Or negative times negative is equals to positive. Negative times positive is equals to negative. This one. Hence, for example, in De Morgan's theorem, the variations will look like the following. This one. So we have here not P and Q is equivalent to P or not Q. If we will negate this one, if we will negate the proposition, it will be changed. If this is and, it will become or. And if this is and, it will become or. And if this is or, it will become and. So for example, we have here, oh, sorry for that. So we have here, so not P and not Q is equivalent to not P or Q. And we also have not P and not Q is equivalent to P or Q. Negative times negative is positive, and negative times negative is equals to negative. Or not P or Q is equivalent to P and not Q. So if this is or, it will become and. If this is and, it will become or. If we will negate the proposition. So, not P or not Q is equivalent to not P and Q. So, please note that the same principle in terms of erations goes to the rest of the rules of replacement. I need not explain them again below. This one, I believe the discussion above, so this one. Okay, we also have here, not P or not Q is equivalent to P and Q. So, for example, so not G and T. Or, we also have the G, the grocery store sells textbooks. T is the toy store sells textbooks. Or we can say that not both the grocery and toy store sells textbooks. Neither the grocery store sells textbooks, nor the toy store sells textbooks. Or it is not the case that the grocery store sells textbooks or the toy store sells textbooks. And for the last one, so this one, the grocery store does not sell textbooks and the toy store does not sell textbooks. That's it. So that is for the De Morgan's theorem. Now, we will move on to the double negation. So when we say double negation, the form of double negation is as follows. This one. P is equivalent to not P. Or negative times negative is equals to positive. That is negation. And always remember that if we will negate something, so if wala po itong open and close parentheses, so for example, wala po itong open and close parentheses, so the answer for this one is not P. If may close and open parentheses po ito, so it will become positive P or P. That is double negation. So in double negation, we can replace not P with P and vice versa, because not P is absolutely the same with P. Hence, not P is equivalent to P. So as we can see, the proposition is a simple proposition because there is no other component proposition with two negation signs not. Thus, if we symbolize the proposition, then we have to symbolize the negation signs accordingly. So, if we let P stands for it is not true that Melbert is not studying, then the proposition is symbolized as this one, not P. Then, but if we analyze the proposition, it is clear that it means Melbert is studying because it is not true that he is not studying. Hence, the proposition can also symbolize as this one, P. Therefore, not P is equivalent to P. Okay, for example, we have here M. The milk is in the fridge. Or not M. The milk is not on the fridge. It is not the case that the milk is not on the fridge. So, therefore, not M. Not M is logically equivalent to M. That is for the double negation. And for the contrapositive or the transposition, if we say contrapositive, hindi po siya positive, kundi negative. So the form of a transposition is as follows. So this one, P implies Q. This one is implies, or like this one, that is implies. P implies Q is equivalent to not P implies, not Q implies not P. Hindi po siya positive, kundi negative. That's why this is negative or may not po ito. Because hindi po siya positive. Siya po ay negative. So, transposition permits the antecedents and consequence of conditional propositions to be interchanged but changing their quality at the same time. So, that is for the contrapositive. So, next we have here the material implication. So, the form of a material implication is as follows. So, P implies Q is equivalent to not P or Q. So, material implication permits conditional and disjunctive propositions to be substituted for one another. So, for instance, if we have the proposition, if it rains today, then the road is wet. That is, P implies Q. Then, it can be replaced by either it does not rain today or the road is wet. So, therefore, that is not P or Q. That is for the material implication. And the next one, we have here the material equivalence. So, in material equivalence, so the forms of a material equivalence. So, here, P, this is conditional. This is what we call the conditional. Okay, this one. Sorry for that. This one, this is conditional. P, conditional Q, is equivalent to P implies Q and Q implies P. Or itong P implies Q and Q implies P. That is the material implication. No, material equivalence. So the first form of material equivalence, this one, says that a biconditional proposition is equivalent to the joint assertion of two conditional propositions. So, for example, the biconditional proposition, the teacher will be absent if and only if he gets sick. So, that is P, or P is equivalent to Q. So, can be replaced by the following proposition. If the teacher will be absent, then he gets sick. And if the teacher gets sick, then he will be absent. So, that is P implies Q and Q implies P. So, the same principle goes to the second form of a material equivalence. So, that is for the material equivalence. And we will proceed to the tautology. So, when we say tautology, so there are two forms of the rule called tautology, or the thought. The first involves disjunction. So, when we say disjunction, it is the or. So, P is equivalent to P or P. So, this is the truth table. So, we have here the P. If we have here the T, so since that P or P is equal to P, so this is T. That's it. That is the tautology. And second involves the conjunction. So conjunctions or the and. P is equivalent to P and P. So in each case, the rule permits replacement of any statement by or with another statement that is simply the disjunction or conjunction of the original with itself. So although such reasoning is rare in ordinary life, it will perform a significant formal role in our construction of proofs of validity. So the last one, I think this is the last one, the exportation. So exportation is a rule of replacement of the form P and Q implies R is equivalent to P is equivalent to P implies the quantity of Q implies R. That is for the exportation. So we have here the truth table. So the truth table demonstrates the statements of these two forms are logically equivalent. So there, for example, we have here the P, the Q, and the R. So if we have here the F, and we have here the F, and we have here the T, so if we will find the value of P and Q, since that and, so therefore we will find the minimum value, so T. So implies R, so therefore the answer is T. And if what is the answer of this one is also the answer of this one, because they are equivalent. So that's it. That is for the exportation. So those are the rules of replacement, the 10 rules of replacement. Again, we have the commutation, association, distribution, De Morgan's rule, double negation, contrapositive or the transposition, the material implication, the material equivalence, the tautology, and the exportation. So I hope that you learned something. So we will answer one example. So for example number one, so we have here show that P implies Q is equivalent to P. Not Q implies not P are logically equivalent. So we will prove this one. So first, we will find this one. So make sure that this one will like this one. So first, we will copy the P implies Q. So P implies Q. Okay, sorry for that. So we will copy first the P implies Q. Then P implies Q, then sorry for that. So first we will copy the P implies Q, then we will use the material implication. So it will become not P or Q. Then next we will use the commutativity or the commutation. So it will become Q or not P. Then we will use the De Morgan's double negation. So it will become not Q or not P. Then next we will have not Q, because as what I've said earlier, if wala po itong open and close parentheses, so ang not P magiging not Q magiging not Q. Then so not Q or not P. Then we will use also the material implication. So it will become not Q implies not P. Okay, that's it. So I hope that you learned something from me. So that's all for this day. So that is for the rules of replacement. So thank you.